Hi, I'm Nisha, and I'll be talking about inkjet printed graphene patterns for water activity sensors. First, I'd like to give a brief introduction on chemiresistors. So, a chemiresistor is a tool that can detect chemical vapors in air, soil, or water. It's a partially conductive polymeric material that swells in the presence of vapors, and the degree of swelling indicates the chemical concentration of the vapor substance, which can be measured through a change in electrical resistance across the sensor. When the presence of chemical vapor disappears, the chemiresistor resets and may be used again. Such a device may be calibrated and used as a hygrometer to sense the relative humidity or water vapor in the air. One reason why sensitive detection of humidity is useful is that in a closed system containing a sample in vapor, liquid, and thermal equilibrium, relative humidity directly reflects the water activity of that sample. Thus, a sensor that can detect relative humidity can serve as a tool for detecting water activity. Developing a partially conductive material with graphene and a water-absorbing polymer could serve as a cheaper, flexible alternative for a water activity sensor. The reason why one would be interested in water activity of a sample is because it actually influences chemical reactions and even spoilage in that sample. According to this chart showing the relationship between reaction rates and water activity, propagation of mold growth starts at water activity of zero point 0.6, yeast growth at zero point 0.8, and bacteria at zero point 0.9. Thus, water activity with a range of zero point 0.6 and above can be considered the critical range of potential product spoilage. By monitoring water activity, we could also monitor product quality and shelf life. Other parameters that also influence product spoilage are pH and temperature, although the form of the sensor described here doesn't measure these. There is actually already a high demand in industry for cheaper, versatile tools to monitor water activity as an indicator of product quality during manufacturing processes, transportation, and storage. The novelty of printing graphene material for use as a water activity sensor is the simplicity of such a device, and it is also relatively cheaper. Also, the sensor could be printed and thus integrated in a variety of substrates that may satisfy diverse demands, like for example, on plastic or paper packaging, on storage fixtures, on manufacturing equipment, and even in production sites like greenhouses. There are several industries in the Philippines that could benefit from a cheap and versatile water activity sensor, such as manufacturers of food, detergents, and even medicinal drugs. Since monitoring water activity could somehow indicate product quality and shelf life in real time, it could be a tool used even by consumers, not just producers, so they know not to throw and waste good products just because it's a little over the indicated expiry date. It would also indicate whether a product is undergoing spoilage before the indicated expiry date. This is especially important for food products and medicinal drugs. I see that the future of any similar sensor, whether it senses water activity, pH, or temperature, would be cheap and mass-producible, with a simple yet accurate system and obvious indicator so that even households may use it. This way, we wouldn't have to risk smelling or tasting bad products when we're trying to figure out if they're still okay. Here are patents showing different designs of water activity sensors based on other concepts. In the patent entitled Water Activity Determination Using Near-Infrared Spectroscopy, near-infrared radiation is used to analyze the samples. The device first needs to be calibrated by correlating water activity at different levels to certain spectral features. They claim that their method can measure water activity in less than 5 minutes, which is relatively quick. The device comprises of a sample holder connected to a computer where the data will be projected and processed. Now another device with a patent entitled Rapid Water Activity Determining Device and Method uses a dew point hygrometer. In this device, a metal surface or a mirror is cooled to condense moisture on the surface, and using an optical system, the cooling of the mirror is adjusted so that the equilibrium dew point or condensation at equilibrium is attained. The temperature at this condensation is then related to relative humidity and thus to water activity. The equilibration of the device takes longer though, up to 10 minutes. Also, the proposed design includes a container where the sample must be placed to establish equilibrium. This is the end of my presentation. Thank you for listening. Here are my references.